In this lesson, we're going to discuss how we can use trig ratios to find missing sides within a right triangle. So as a reminder, let's write down the definitions of the three trig ratios within a right triangle again. The sine of one of the acute angles within a right triangle, which we'll abbreviate theta, is the ratio of the leg opposite to that angle to the hypotenuse of the right triangle, so opposite over hypotenuse. The cosine of an acute angle within a right triangle is the ratio of the leg that's adjacent to that angle to the hypotenuse of the right triangle, so that'd be adjacent over hypotenuse. And finally, the tangent of an acute angle within a right triangle is the ratio of the opposite leg to that angle to the adjacent leg to that angle. And certainly the expression SOHCAHTOA can help you remember how these three ratios work. Now keep in mind that what you consider to be opposite and adjacent is based on looking from one of the acute angles within a right triangle. So let's suppose that our angle theta was marked down here. Now if we're going to label this triangle with respect to that angle theta, that kind of determines how we look at things. Well, let's say the first thing we'd always know is that the side across from the 90-degree angle, that's definitely called the hypotenuse. And what we consider to be opposite to this angle theta would actually be this side over here. So the opposite leg would be labeled over here if we're looking from that angle theta. And the adjacent leg would be this leg right next to that angle theta down here. So again, we'd label this leg to be adjacent. Now, be careful with adjacent and hypotenuse. I would always recommend label the hypotenuse first. Even though the hypotenuse is next to that angle theta, what you call adjacent when you're doing trig ratios is always a leg. Now let's suppose the way we looked at this picture changed. Let's suppose our angle theta was up here. Again, the side we call the hypotenuse is always the side across from the 90-degree angle, so that'd be this side right here. But now the leg that we consider to be opposite to angle theta is actually this side down here. So this leg would get labeled opposite to that angle theta, which means this leg over here would get labeled to be adjacent to angle theta, or next to angle theta. So keep in mind, these trig functions are based on looking from that angle theta, which really determines your perspective on that right triangle. In our first example, we're asked to determine the value of one of the missing sides of this right triangle. Well, looking at what we're given here, I notice that across from the 90-degree angle is this measurement of 12. So right away I'm going to label that as h for the hypotenuse of this right triangle. And now we're given this 28-degree angle down here, and if you look from that 28-degree angle, this missing side over here that's labeled with x would be a leg that's opposite to that 28-degree angle. Again, if you're looking from that 28-degree angle, you consider that side x to be opposite of that 28-degree angle. It's the leg that's opposite to it. Now let's see if we can apply one of our trig ratios, sine, cosine, or tangent, to find the missing side of this right triangle. So again, the helpful memory trick is SOHCAHTOA, if you remember how the three trig ratios work that we're dealing with in this class. So let's see, if we have opposite and hypotenuse, it looks like we could write down a statement about the sine of that 28-degree angle. In this diagram, the sine of that 28-degree angle would be equal to opposite over hypotenuse, which would be x over 12. Again, x is the leg that's opposite to that 28-degree angle, and 12 is definitely the hypotenuse. So what we just created is an equation that has one variable, which is that value of x. So what I'm going to do is rewrite this just to emphasize how you'd write down the original statement, and also the steps you'd go through to solve it. Alright, well let's see. If I want to get x by itself, one thing we can do is multiply by 12 on both sides of this equation. So I'm going to multiply by 12 on the right-hand side, which would clear that fraction out. And to keep things balanced, I'll multiply by 12 on the left-hand side as well. Now, keep in mind, sine of 28 degrees is actually a value your calculator has stored in it. And when you multiply by 12, that doesn't interact with the input there of 28 degrees. You would just say 12 times the sine of 28 degrees equals that value of x that we want to find. Now in a minute, I'm going to go to a calculator screen and show you exactly how to work this out in the calculator. And what we'll get is that x is approximately equal to 5.634. Again, 3 decimal places is a good rounding rule to follow in this class. So the good news is your calculator has that value of sine of 28 degrees stored right in it. So we'll go to the calculator screen and I'll see how this would work out.
Let's go through how to use the graphing calculator to evaluate different trig functions. In the last problem, I think we had to work out 12 times the sine of 28 degrees. So let's see how we do that in the calculator. The first thing we want to check is that we're set up in the right mode. So on the top line here, you'll notice there's this mode button. I'd like you to press mode. We have to make sure our calculator is set to measure angles in degrees. On the third line down, you'll notice there's this option for radians and this option for degrees. You want to make sure your calculator is set up just like this one, where degrees is highlighted on that line. So if right now radians is highlighted, you might have to go down to that line and tab over to degrees and press enter to make sure it's set in degree mode. Now once you've done that and you made sure you're set up in degree mode just like this one, let's quit out of the mode menu. So we'll press the second key here in blue and then press quit, which is right above mode. It's kind of convenient. Alright, so let's see how our calculator works in inputting trig functions. In that last example, part of the problem was the sine of 28 degrees, which your calculator has stored right in it. If you press sine, it will ask you for, again, the angle you want to input, which was 28 degrees, I think, and then press enter, and your calculator has that value stored in it. Now in that problem, I think we had to work out 12 times the sine of 28 degrees, though. You can actually do that in one line, and I would recommend doing that. What we'll type in is 12 times the sine of 28 degrees. Okay, we'll input that 28, close off, and press enter. And that will get us the value of the missing side that we had to find in that example, which I think we rounded off to 5.634. So you'll notice here you have 5.633, and the fourth digit is a 6. It would round that third digit up to a 4. So again, your graphing calculator can totally handle entering that expression on one line. I would recommend doing that. It's got the value of sine of 28 stored in it, then it'll just multiply it by 12 there. So that's a quick intro to how to use the graphing calculator to input different trig values that you might need to find in the course of a solving problem.
So now that we've seen how to set up a trig ratio to find a missing side within a right triangle, and also how our calculator works in terms of inputting trig functions, let's look at another example where there's two missing sides. So again, carefully take a look at the way this diagram is set up. Notice the 90-degree angle is right here, and across from it is that value of y. So right away you should label that as h for hypotenuse. And if we're given this 20-degree angle up here, let's base our trig ratios on that 20-degree angle. Now looking from that 20-degree angle, the leg that's opposite to that 20-degree angle is this one over here that has a value of x on it. So we'll label that as opposite. And the leg that's next to that 20-degree angle, or adjacent to it, is this leg over here that has the value of 15. Again, don't get confused with adjacent. The adjacent side would always be a leg, not the hypotenuse. We already labeled that. Okay, so now let's see what our three trig ratios would say here. Again, helpful memory trick is SOHCAHTOA. Well, let's see. Looking from that 20-degree angle, it might not be terribly useful to use the sine function. So if we said the sine of 20 degrees here, what that's equal to is opposite over hypotenuse, which happens to be x over y. Notice that that has two unknowns in it right now, which means we couldn't find either missing side just using that equation right now. Sine of 20 degrees equals x over y. That has two unknowns. It's not going to be terribly useful to us. Now on the other hand, if we wrote down, say, the tangent of that 20-degree angle, that's going to be equal to opposite to adjacent, which is x over 15. There's only one unknown in that equation, so we can definitely solve that for x. And if we wrote down the cosine of that 20-degree angle, notice that although we don't know the hypotenuse, we do have the adjacent leg, so adjacent to hypotenuse here would be 15 over y. Cosine of that 20-degree angle would be 15 over y. Okay, so for that first equation, tangent of 20 equals x over 15. The steps are very similar to the last example. We'd multiply by 15 on the right-hand side, and also 15 on the left-hand side. That fraction would clear out. We'd find that 15 times the tangent of 20 would be the value of x. Again, if you input that into your calculator, you'll get that x is approximately 5.460 if you go to 3 decimal places. Now this next equation is a little different. I'm going to rewrite it just to emphasize the solving steps. So we'll write cosine of 20 would equal 15 over y. Notice where the variable is located this time. It's in the denominator. However, I'm still going to clear out that fraction first. I'm going to multiply by y on the right-hand side and by y on the left-hand side. Again, keep things balanced. That fraction would clear out. And now you have y times the cosine of 20 degrees would equal 15. Again, the input of that cosine function of 20 degrees stays as it is. That y now is now a coefficient in front of that cosine of 20. And notice that y is still not by itself yet. There's still one more step we'd have to go through here. To get y by itself, we're going to divide both sides by the cosine of 20 degrees. Again, we'll divide this side by the cosine of 20 degrees. So in the end, y ends up being equal to exactly 15 divided by the cosine of 20 degrees. So on your calculator, be careful when typing that in. You want to type in 15 divided by the cosine of 20 degrees, which works out to be approximately 15.963. Again, if you go to 3 decimal places. So again, y is approximately 15.963. So the solving was a little different in that second equation just because the variable was in the denominator. But again, steps are very similar. Clear out that denominator, and there's just one extra step of dividing to get that variable by itself. To end this lesson, here's a couple of practice questions for you to try on your own. In each diagram, you're asked to determine the value of x, which is one of the missing sides of the right triangle. So keep in mind that you'll want to carefully figure out which trig ratio applies best in each one of these problems, sine, cosine, or tangent.